Hello guys, hope all of you are doing great. In my previous video, I told you about conditional jumping or conditional branching and unconditional branching. Now in this part of the video, we are going to see some more of this conditional jumping along with this compare instruction. Say for example, you have to write any one of these programs, like program to find the bigger of two numbers, program to find if an alphabet is in uppercase or lowercase, find the biggest of three given numbers, find if a number is even or odd, find if a number is positive or negative. Say for example, all these programs, if you want to write, you can actually make use of this compare instruction along with this conditional jumping. Okay, then let's see how we can do that. So let me tell you a few things about this compare instruction first, and then I'll try to write maybe one or two of these programs. Okay, then let's begin. This compare instruction, as most probably the name indicates, it compares two values. It needs two operands actually. Okay, like say for example, operand 1 comma operand 2. Right now I'm only saying that it compares two operands. Okay, now let's first learn a few things about these operands. Now see here, when I say these operands here, the three possible things might come, at least three things might come here in the place of an operand. Say for example, it could be a register, it could be a memory location. Memory means like something there in the data segment, or it could be an immediate data, like say for example 5/8, 10/8, like that. So for this operand 1, immediate data is not possible. Okay, so for operand 1, only two possibilities: it could be the register or memory. For operand 2, it could be at the same time, it could be register, it could be memory, or it could be immediate data. Now see how many these different possible combinations. Either it could be register to register, or it could be register to memory, or it could be register and immediate data. Similarly, it could be memory or register, or it could be, see here, I'm saying memory or memory and memory or immediate. But out of these memory or memory, this thing is not allowed. Other than that, these other combinations are allowed. What I mean is, say for example, you have a register AX and BX, so you can write like compare AX comma BX. Till now, I have not said you anything about like how we can actually check the results of these compare instructions. I'm just telling you about these operands. Okay, you can write these things. So you can also write like say compare AX with an immediate data, say 9. Or you can do like compare, this thing is not allowed, 9 comma AX. This might show you an error message. Okay, and then you can write, say for example, you have a variable A. That is what I mean by variable is, say for example, you have declared in the data segment a variable, say A or A1, and it is of say 16-bit, and you store some number there, say 9. And then you can write in that case compare A1 comma AX, or you can write compare AX comma A1, like this. Okay, so all these things are possible. Okay, then I told you about like what these different operands could be. Okay, now once this thing is clear, then next question is, okay, now we know like how to write a compare instruction, and we also know about the different about the types of, or about the possibilities of these different operands, these two operands. Then the next question is how we can make use of the result of this compare instruction. To make use of the result of the compare instruction, what we can do is we can actually make use of some conditional jump instruction. So for example, you see here, like say for let me write it in this way: compare operand 1 comma operand 2. The first operand I'm calling as operand 1, and the second one I'm calling as operand 2. Then these different conditional jump instruction you can use. Say one jump instruction is say jump on equal. You read this thing as jump on equal, and this will be true. This jump on equal condition will be true. It is true if O1 is equal to O2. So here you know in C program what does equal equal do? Equal equal does it just checks whether both these two values are same or not. Same thing we can achieve just by writing compare instruction, and after that immediately checking whether this equal flag means actually zero flag. This thing is same as writing jump on zero. Okay, whether zero flag or equal flag is set or not. If it is true, I mean these conditional jump instruction will be true if O1 is equal to 2 or equal to O2. It means the values that you are comparing, they are equal. Okay, or what you can do is you can also do like say jump on not equal. This condition will be true. This conditional jumping will be true if O1 is not equal to O2. Okay, and also what you can do is you can check obviously like jump on say. Yeah, these are things. You just think O1 and O2 in terms of numbers. So in that case, what are the other possibilities if O1 is greater than O2 or not? Okay. So if you want to check if O1 is greater than O2 or not, what you have to do is you can make use of this jump. Okay, there are two options actually. Let me write both of them. Jump above. Jump above condition will be true if O1, the first operand, is bigger than the second operand. Similarly, you can also write like say it is bigger than, no? If it is bigger than also, you know, like jump above or equal, it means this condition will become true if O1 is greater than or equal to O2. Similarly, like this above, the other counterpart is your, below. So jump below, it will be true if O1 is less than, O1 is below O2. Or jump below or equal, it will be true if O1 is less than or equal to O2. And obviously, you can also write like jump not above or equal, jump not below or equal. But if you know how to use these few, then obviously you know how to use the rest of the things. Now, one important thing, let me tell you here, these above and below, and they're like, different versions. They are for these above and below. These are for, like when you are comparing unsigned numbers or unsigned values. But if you're comparing signed numbers, then what you have to do is you have to instead jump above. Instead of jump above, you will be using jump greater than. Or instead of jump below, you will be using jump less than. And there are different versions, okay? Like jump greater than or equal, jump less than or equal, jump not greater than, jump not less than, like those variations. But point here is that if you are using unsigned, you are doing unsigned comparison, then you'll be using above and below. If you are doing signed comparison, then instead of using above and below, you'll be using greater than and less than. If you are using signed comparison. Okay, so that's something that you need to keep in mind when you actually want to make use of the result or make use of this compare instruction with jump instructions. We'll be seeing examples, then these things will become clear. Okay, so now we have seen how we can make use of this compare instruction with jump instruction to verify different possible conditions. Now let's make use of these. Okay, then let's first write a simple program and then see how it works. Okay, let's say for example we start with a very simple program that write a program to check check if the given number okay, let's write this program. Write a program to not check actually. Write a program to find, sorry, write a, oh, oops, sorry. Write a program to find the bigger of two given numbers. Okay, say a comma a1 comma b1. Now what output we want, what output we expect from this program is, if a1 is bigger than b1, then it should display two possible outputs will come. Okay, like write a program to find the bigger of two given numbers. Okay, so either it will display a1 is the bigger one, or it will display b1 is the bigger one. These two possible outputs we want. Now see, you might be thinking, if what happens when both the numbers are same, then any one of this a1 is the bigger or b1 is the bigger will be displayed on the screen. Just for the time being, assume that there are two possible outputs, either a1 is the bigger one or b1 is the bigger one based on their values. That's what we want in our program. Okay, now if we have to write this program, then what we can do is actually you see how we can write this program. First, let me first write it here, and then maybe I have to explain you something, and then we'll be writing it in the code segment. Okay, so the first thing that is okay, let me directly write it in the code segment. So this is what we want. So let's open this Visual Studio Code, and then this is the skeleton of the program already written in my case. But in your case, if it is not written, please pause the video and type this much. Once you typed, then you can again, start typing with me. Now, one request I want to make you people, please execute this program, right? Because these programs are small programs, and that's why I'm not sharing my code with you people. But although I have not shared it in that way, but since only a few lines of code, you can actually pause the video any moment of time, and you can, type the code, and you can check the output by yourself. That will certainly give you a good idea about the things which are happening. And again, maybe I have already told you, uh, this is all about programming. I mean, you should not feel like 8086 is a programming language which nobody uses. It's not that. As a programmer, you should be happy with any programming language. Any programming language is actually, uh, important in some sense. Okay. So as a programmer, it's like, you should be able to deal with any programming language. So because see here, programming language only it's sort of a framework where you have to implement your logic. The logic part doesn't change over programming languages. That people should comprehend actually. The logic is same. I mean, no matter in what programming language you're writing the code, more or less you'll be using the same logic to solve the same problem. Only thing is that based on the available features in that particular programming language, you will write your code accordingly. So, point is that programming is programming. So don't you think like it's sort of not less important or something like that. Don't measure it that way actually. Okay, anyhow, what we were doing was, yeah, I was telling you about this compare instruction. Let's first write. Uh, we were writing this program like we want to check if we want to find the bigger of two numbers. Say, for example, you just assume that we have two numbers, a1, it's a word for the time being, and say let's the number is 23. It could be anything basically, okay? And then b1 is another word, say it's, let's say 21. And then we have to find out whether a1 is bigger or b1 is bigger. And since we'll be displaying two strings as an output, so let me store them also. Like say, I call string one as it's, it's an array of bytes actually. So here I write a1 is bigger mark it by this dollar symbol, mark the n by dollar symbol, and similar string we want, and let's call it string 2, and it here in this case it is b1 is the bigger string. Done. So this much we need, I guess, in the data segment, and after that let's write the code. So what we want, see here, let's start it in this way. At some point of time, anyhow, we have to display this string 1 either or string 2. So it means what? At least somewhere we have to display string 1, somewhere we have to display string 2. So let's first write that part of the code, okay? So we know how to display string on the screen. Yeah, it's load the effective address of the string to DX register, say it is string 1, and then move the number 09H to AH register, and then we have to call this interrupt service routine by writing int21h. This will display string 1 on the screen. Similarly, if we have to display string 2, then we'll be writing here, instead of storing the base address of string 1 in DX, we'll be storing the base address of string 2 in DX. And the rest of the things are same. And once it is done, now, okay, it is done. The 2 blocks of code we already have written. And after that, what we want is, we want like to compare. I mean, now we have to decide which block is to be executed, whether we want to execute this block or we want to execute this block. And that decision will be taken based on the values which are there in A1 and B1. Okay. So for that reason, what we're going to do is we're going to make use of this compare instruction. We'll be comparing A1. See here, as I said, both these two operands cannot be memory locations, cannot be memory operands. Okay, so one of them at least would be either register or immediate. So here what we do is, for that reason, first we copy to AX register the content of the number A1. Okay, it means whatever it is A1, now it is in AX. So we can write now compare, we can now write compare these AX register with, say, we're comparing the first number is whatever it is A1, which is now in AX, with this B1. Okay, so basically we're comparing A1 with B1. Now, what we want is, now, how do we get the result? Now, we want to know which one is bigger. So we can write now jump on. See here, as I said, now if whether we are comparing signed number or unsigned number, that's the question. So for the time being, you just assume that these numbers are unsigned numbers. So for that reason, we can use jump above. Jump above when this condition will be true, as I said in my introduction. Jump above will be true if O1 is greater than O2. Or we can use jump above or equal, but let's use first jump above. Jump above will be true if O1 is greater than O2. It means if AX is greater than B1. If A1 is greater than B1. That condition will be true if A1 is greater than B1. Okay, so jump above, if it is the case A1 is greater than B1, it means we want to display this, or we want to execute this block of code. So let me call this block of code as A1 block. And so if jump above is true, then we want to execute A1. And then if it is not true, jump above is not true, then we can write here directly jump not above, or even we can directly write here this block of code actually. Yeah, this way also you can write. See, there are different ways you can write the code. See here why it will work. If it is above, then it will transfer the control to this particular point. But if it is not above, directly it will execute this block of code. All right. Yeah, you might be thinking, you are right, actually, whatever you're thinking. See, after executing this block of code, we again see if we do not write anything here, immediately the control will flow through this block of code also. But we want to prevent it. So for that reason, we can write here jump. After displaying string 2, we can transfer the control to this last terminate instruction. And here also you can write like jump terminate, but since nothing is there after this 21a, directly it is by default this terminate is coming here. So you can, if you want, you can omit typing, or if you want, you can type also. In both ways, it will show the same output. Now let's see whether this program is right or wrong. Okay, because I'm speaking at the same time, so I might do some mistake. First thing is we are copying in AX register whatever it is in A1, and then we're comparing the first value, first A1 with B1 sort of, and jump on above. This condition will be true, as we know, only when the first operand is bigger than the second operand. So if it is the case, if the first operand is bigger than the second operand, this condition will be true. And if it is true, then we are executing, we're transferring our control to A1. It means here. And as a result, it will display string 1 on the screen. It means A1 is bigger will be displayed on the screen. And after that, immediately terminate the program. Done. Now, what if this condition is not true? If this condition is not true, then it will be skipped. And after that, next instruction is load the effective address of string 2 to dx. It means whatever it is there in string 2, now that will be displayed on the screen as an output here up to this point. And then after this, see, immediately terminate is there. So it will skip this block of code, and then it will mark the end of the program. So if two numbers are same, then in this case, say for example, now let's mentally try this program, 23 and 21. What will happen here? Move ax comma a1. So 23 will be the content of ax. And then we are comparing whether 23 is greater than, we're comparing 23 and 21. Since the first number is bigger than the second number, jump above will be true. And since jump above is true, it will be displaying you, it will take the control to this point, and then it will display you A1 is bigger. Done. So for example, both these numbers are same, 23 and 23. Then what will happen? AX is now 23, B1 is 23. So jump above condition will be false, because 23 is not above 23. So this condition will be false. Now, if this condition is false, it will be skipped simply. And then the next instruction is load the string 2. It means if both these numbers are same, then it will display you the B1 is the bigger number. And if obviously if this second number is bigger, then certainly again we'll be comparing, like AX is now 23, B1 is 230, so jump on above. So certainly 23 is not bigger than 230, so this condition will be false. So as a result, it will display you string 2, that is B1 is bigger. Okay, so that should be our output. Now let's execute this program and check our understanding. So for that reason, I'll be first compiling the program. Wow, there are two errors. Why is it so? Argument to operation or instruction has illegal size, symbol already different, kind A1. Okay, let me see what could be the mistake. Data segment A1 DW23, B1 DW. Oh, here 230, no, 230. Maybe in hexadecimal, is it a large number? No. Oh, but anyhow, I'll come to this point. And then string 1 dba1 is bigger. String 2 dbb1 is bigger. Code ax comma data. Okay, no problem. Move ax comma a1. Okay. Compare ax comma b1. Where is it showing me the error? Line number 6 and line number 16 and line number 22. Let's see what are those lines. 16 and 22. A1. Jump. Oh, sorry. I already have this A1 there now. So let me call it, say, for example, okay, level 1. And then here it is level 1. Now I have autosave on, but in your case, if it is not on, save the program and then again compile the program. This time errors are gone. So we are ready to link. Okay, and then we are ready to execute. I'll be executing it directly. Let's see what is the output. Now to do that, first let's make sure what are the values. A1 is smaller than B1, so it's the output should be B1 is bigger. Okay, in this case, with the, if I specify the value of A1 as 23 and B1 as 230, in that case B1 is bigger should come on the screen. Okay, let's execute pp8. So it is saying B1 is bigger. Let's make them equal, 23 and 23. In this case, let's see what is the output. B1 is bigger again. Now again, let's make this number smaller. A1 is bigger should come this time. And I'm writing custom, okay, compiling it, linking it, and then executing it. A1 is bigger. Okay, you got the right output. Here you can see, right? Now, I was about to tell you something. I guess you people got this program, right? I mean, this is quite simple and straightforward program actually. You also can try it by yourself, and you should be able to do it by yourself actually. Okay, done. And what else I wanted to tell you? Okay, let's say for example now, I said you here, no, these above and you know these above, you can write the same program using below also, like jump below and jump below, not below, like that. Okay, but here, as I said, no, these are jump above and jump below are useful when you are using or you are doing unsigned numbers. You are doing unsigned comparisons. Okay, now if you are using signed comparisons, then these jump above and jump below might not give you the right output. What I mean by sign comparison is, let's say, store this number A1 is 23, fine, but okay, let's simple store a small number here. Let's say the number is 3. In A1 it is 3, in B1 it is 2. But in A1 actually instead of storing 3, let's store -3. Okay, so we know that -3 is smaller than 2. So in that case, what output here it should display, this program should display B1 is bigger, certainly, isn't it? Because B1 is the bigger number. Let's see whether it gives us B1 is bigger or not. Okay, compile this program, link. Here it is saying, see, our expectation was it is showing us A1 is bigger, but certainly A1 is -3. -3 is not bigger than 2. Right? So it means here, see, it is actually what it is doing is it is doing unsigned comparison, sort of. Okay, but if we want to consider this sign comparison, like the sign of these operands, then what we have to do is we have to actually make use of this code. We have to change, like as I said, we cannot use jump above, jump below. We have to use jump greater than, jump less than. So wherever we have used this above, we will be using now jump greater than. So jump greater than L1, and that's all. Now let's compile the program and check the output. Now it is saying B1 is bigger. So it means here this B1 is bigger, and certainly B1 is bigger. Okay, and then let's this greater will work, I guess, if I write here now this 3 again, and both of them are positive numbers, then also it should work. It will be considered as +3 and it will be considered as +2. Obviously, +3 is bigger than +2, so here it will be displaying me A1 is bigger than A2, B1. Okay, let's compile this program. Sorry, compile this program, link this program, and execute it. So our expectation is A1 is bigger. It's showing A1 is bigger. Okay, so you can use actually a greater JZ or JL if you are doing signed, if you're not dealing with signed numbers. That is, if your numbers are both in positive and negative then you can use this, you know, jump greater than and jump less than instead of jump above and jump below. Okay, so now we know, like you people now know how to make use of these compare and jump instruction together. They're different, as I said. No, here also, as in my previous video, also I have shared this doc with you people. You can actually see in this doc here, like different conditional jump instructions are there. See, I have told you about jump above and jump not below or equal. Both of them are equivalent actually, or jump above equal, jump not below. like that. So these I have shown you. Similarly, jump greater than. See here, jump above used to jump if above not below equal instruction satisfies. Used to jump if greater not less than or equal instruction satisfies. Above and below you'll be using on for unsigned number, and greater than and less than you'll be using for signed numbers. This different jump instruction, you can actually see it by yourself. I'll be as I said now in my previous video also, I shared this document here. Also in this video's description also you'll get the link, so you can click on the link and you can get this document, and then you can verify these different jump instructions. You can go through them. Okay, then we have seen more or less how we can use compare instruction with conditional jumping. Now, as I already have written this program, find the number, the bigger of the two number, right? Now let me write this one, like write a program to find if, not this one, okay, this one, find the biggest of three given numbers. Because here, see, biggest of three given numbers means you have to write a few more if-else statement actually. How do we find the biggest of three numbers? Let's first try to do it using a flowchart, and then we'll be writing the code. Again, see, programming is, it means like first you need to know what is the logic, and then actually you'll be writing the logic in a specific programming language. See here, you know, how do you speak the thing? That is also important. I mean, you know, the content of your, you know, the content of the things that you speak is important. Um, Obviously, the language that you use to explain the content, that is also important, but the content is, you know, an independent thing from the language. Same thing is true with programming also. This most probably at the beginning also I said, but anyhow, the logic part usually remains same. Okay, so let's our problem now, what problem we're trying to solve is we want to find like the biggest of three given numbers. Okay, like we want to find the biggest of three given numbers. How do we do that? To do that thing, let's do it in a flowchart. First thing is, say we are given these three numbers, say A, B, and C. First, we will be comparing any two numbers, say A and B. We'll be comparing A and B. If A is greater than or equal to B, if A is greater than or equal to B, either this condition is true or this condition is false, isn't it? I'm checking, or I'm saying that A is greater than or equal to B. No matter what value these A and B have, either this condition is true or false. Now, if this condition is true, let's assume for some given value of a, b, this condition is true. It means what? A is greater than or equal to b. It means what we can do is we can eliminate b. We can eliminate b from the the contest, right? Okay, sorry. Yeah, like this. B is now gone. You might be thinking why B is gone. A is certainly greater than or equal to B. So anyhow, A is if A is greater than or equal to B, if A is strictly greater than B, certainly B cannot be the largest number. But if even A is equal to B, then also we can safely say that A is the largest number in some way. Okay, so that way you should understand that if this condition is true, it means it directly eliminates B from the contest. So if B is eliminated from the contest, then what are the other numbers that we have? The other numbers that we have left to it is like A and C. A and C. Now it is a question of finding the bigger of two numbers, isn't it? So what we can do is, again, we can check a condition. If A is greater than or equal to C. So if it is the case, if it is true, then if it is true, then C is immediately eliminated from the contest. So if C is eliminated, B is eliminated, then who left? A left. So we can now safely say that A is the biggest number. It means A is greater than B, true. A is greater than C, true. It means A is greater than both B and C. So obviously A is the largest number, right? Now so A is greater than B, true. So B is eliminated. Now between these two, if this condition is false, if A is not greater than or equal to C, it means A is less than C. It means C is bigger than A. Okay. So since C is bigger than A, so we can say like if this condition is false, then certainly C is bigger than A. It means A is eliminated from the contest. Now see, B is eliminated, A is eliminated. So who left? C. So C is the largest number. Okay. Now the same thing we can actually extend here also. Like now the false. If A is greater than equal to B, that is false statement. That condition is for some value of A and B, this is not true. So as soon as you know that this is not true, it means who is eliminated from here? B is this condition is false. This condition is not true. It means A is not greater than or equal to B. It means A is less than B. Okay. So if A is less than B, then this A is actually eliminated from the contest. Now, if A is eliminated from the contest, what are the other two numbers we have now? We have this B and C. Now we can check if B is greater than C or not. Here also the same logic. If it is true, then B is greater than C. If it is true, then C is eliminated. Now see A and C, if they are gone, who left? B left. So B is the largest number. Now, if this condition is false, it means B is greater than equal to C. That is false. It means B is less than C. So if B is less than C, then who is eliminated? B is eliminated. Now see, A is eliminated, B is eliminated. So who left? C left. So C must be the largest number. Okay, here it means see B is greater than A and C is greater than B. B is greater than A and C is greater than B. C is greater than B. So, C is the largest number. So that way. So you should, now this is the flowchart. Now, once these outputs are generated, we want after directly, see here, this is the block of code that will display the output actually. These are the like final blocks which will be executed after all these if else's. After executing all these blocks, like any one of these blocks, and again, you have to remember any one of these blocks will be executed at any point of time. That is, if we consider them as different parts, then the end of the program can be reached only by following exactly one path. Either it could be let me draw it using a different color. Either it could be this path, or it could be up to this part it is same, and then from here it takes a different route and then it goes to this. It could be this one, or it could be this one, or it could be this one. There are different paths through which this end can be reached from this say start. Okay, yeah, that is true. Different paths are there, but the thing is, in one execution, at most or exactly one path will be taken. The program cannot take more than one path in one execution. Like if these values of A, B's, and C's are fixed, then always it will take the same path to reach this end. You should comprehend that point. Okay, but anyhow, this is the flowchart of finding the biggest of three given numbers. Now, what we can do is you can now convert this flowchart into a program in any programming language. You can convert it in using C, using JavaScript, using PHP, using Python, using C#, using C++, using 8086, right? Okay, so we'll be doing it now using 8086 programming. Okay, let's do it. Let's try to do it. What I'll do is I'll create a new. I'll be copying it, and I'll create a new file. I'll call it pp9.asm, and I'll be pasting it here. And again, what I'm going to do is basically I'm going to delete everything. I'll start writing up except the here, yeah, except the skeleton. This thing here up to terminate. This is the skeleton of the program, right? And then what we want to print the biggest of three numbers. So three different possible outcomes we want. So again, the same policy. String one is the output when A1 is the largest. You might be thinking, why am I, displaying the output just by writing the name of the variable? Why not the actual value of the variable I'm displaying? Yeah, that's a problem that that we talked about in the previous video also. And we will see how to handle that issue maybe in the next video or next to next video. I'm not postponing it infinitely. It's just that before that we need to, as I said, no, we need to know some more things, and those things are actually we are learning. So once we are done with those other concepts, important concepts, we'll be writing that program also. But for the time being, I'll simply write the name of the variable to display it in the output. So A1 is the largest, LARGEST. Then we have to use this dollar to mark the end of the line, I mean string. And similarly, I need two other strings where my string 2 is and string 3 here. A1, then B1, and then C1 is the largest. These three possible outputs we want, right? And also, we know at some point of time, anyhow, we'll be displaying those three strings. So let me give them some name and say, for example, I call level 1, and here load the effective address of of the string str1 to dx register. Yes, and then move the special value 09H to AH register, and then call this interrupt service routine by writing int21H. And then, since we see here, after executing any block of code where we want our control to go to the end of the program, in this case, right? So we'll be writing here jump unconditionally after executing this part, unconditionally jump to the level terminate. Done. Similarly for L2 and L3. L2 and L3. These are my, okay, here if you see, here, just a second, I just, okay. Here you see, this A1, A is coming how many times? C is coming how many times you see? C is coming twice here. This is one C, and here C. And A and B, they are coming, one. Although C is coming twice, it is the same block of code. Okay, like what we're doing is we're calling this block of code L1, B block of code L2, and this is L3. So both these two blocks are actually the same block. Do you understand this? Just pause the video for a moment and you can actually confirm what I said is making sense. Okay, then yeah, L1 is done, L2 is done. This is my L2. In case of L2, I'll be copying the starting address of string 2. In case of L3, I'll be copying the starting address of string 3, and then done. Now L1, L2, L3 blocks are ready. C is what? L3. Okay, and then what we want is first we want to compare like this. We are going to convert this flowchart to a program. Okay, so what we're going to do is we have to declare three variables, and then there we have to store numbers. That we did actually. Oh no, we have not done. So let's do it then. First declare three variables. So we'll be declaring a1 dw and store some numbers. Say for example 5, and I will need two more similar variables. So like this, say I'm calling it B1, I'm calling it C1, and I'm storing 5. Here says 6, here says 7. So C1 is the largest number, should be the output if we keep the values of A1, B1, C1 in this way. Done. Now after that, what we want, let's see this diagram again. We want to compare A and B. Okay, let's do it first. Compare, again you see we cannot compare two variables directly or two memory locations directly, so for that reason I'll be copying AX to AX. I'll be copying A1, and then I'll be compare AX register with the variable B1. We are comparing ultimately A1 with B1, and then what we want to do is if a1 is greater than, or if a is greater than or equal to b, if it is true, then we want to execute something, and if it is false, then we want to execute something else. That's a point here. How do we do that? Okay, let's do it. If so if a1 is greater than b1, so which flag we have to check? We have to check like jump on, say we are dealing with signed numbers, so we are writing jump on greater than or equal to. Okay, jump on greater than or equal to. If it means we're checking this thing, if the first operand is greater than or equal to the second operand, in that case what we'll be doing is we'll be executing this block of code actually. Now this is a separate block, and if it is false, then this left branch will be executed. Okay, so let me write it this way. If it is true, then I'm calling it, say, transferring the control to right branch. I'm calling it right branch, branch. You might be thinking, what is this right branch? Yeah, I have not given this. I'm just using the label. I have not written actually the code for right branch. Just let me write it in this way first. Now, if it is greater than equal to, if a is greater than equal to b, if it is true, then right branch will be executed. Otherwise, left branch will be executed. Okay, so otherwise, this left branch will be executed. Okay, now what should be there in the right branch and left branch? Okay, let's first write it. Right branch should be right branch. Now I'm writing the code for right branch. Here, what we want to do is, let's first finish writing it. We have to compare A with C. In the right branch, if the control reaches to right branch, then we have to compare A with C. So what we'll be doing is to compare A with C. First, I'll be moving move AX comma A with C. So we'll be copying move. Maybe already A is there in AX, but still I'm just copying it. Move A1 to AX register and then compare this AX register with this variable C1. And then what? We have to check jump. Again, we will be checking jump greater than or equal to. If it is true, then we'll be executing this block of code. Otherwise, we'll be executing this block of code. These two blocks are already written. Okay, so how we can write jump greater than or equal to, we want to execute which block? If it is greater than or equal, a is greater than or equal to C, it means we have to execute block L1. So we'll be jumping our, we'll be transferring our control to block L1, right? But if it is not greater than, see here, what is the other one? Other possibility is the else part. Else part means what? A greater than or equal to is not true. It means we want to check if it is not greater than or equal to, or if it is less than, actually see. If it is not greater than or equal to, then it is certainly less than, right? So we can explicitly write it in this way. Jump on less than. If it is less than, then what we want to do, if it is less than this, I mean, if A1 is less than C, strictly less than C, then we want to actually execute this L3 block of code. So we'll be writing here L3 block of code. Done. And after that, what we want? We have done L1 or L3. Any one of these block will be actually executed. Either L1, it will transfer the control to either L1, or it will transfer the control to L3. And see here, only these two possible things might happen. If this is true, then certainly it will immediately come here. But if it is false, then it must be true. See here, if, why is it so? If AX is not greater than or equal to C1, it means AX is neither greater than C1 and AX is not equal to C1. Then only possibility left is that AX is less than C1, right? So that way, jump less than condition will be true. And if it becomes true, then immediately it will transfer the control to this point. Okay, so it means our right part is done. Our right part is done. Now we are ready to write the left part of the, or left branch. Our right branch is done. So you might be thinking, sir, why we have not written here jump terminate? Because as I said, no, if this is true, then it will transfer it to here, and if it is not true, then certainly it will be true. So that way, immediately the control will go here. So that way, whatever you write here, this particular instruction, no matter what instruction you write here, that instruction will never get the control. Okay, that instruction is sort of unreachable code. You should realize that point. Okay. Okay. Now, said that our right branch is done. Now we have to write the left branch. See here, I wrote jump greater than or equal to right branch. If AX is greater than or equal to B1, then this thing will happen. It means what? Here in this diagram, if A is greater than or equal to B, then this right part will happen. And we wrote the code for this right part. Now we have to write the code for the left part. Now that's what we're doing here. So in the left part, what we have to do is we have to again compare B and C. We have to compare now B and C. So for that reason, first I'll be copying B and C. So I'll be copying to AX register the value of the variable B1, and then I'll be comparing move. Oh, sorry. Then I'll be comparing these AX register with this C1 register. So ultimately, I'm comparing B1 with C1. I'm comparing B1 with C1 or B with C. Okay. Now, this condition is again could be either true or false. Like if B is greater than or equal to C, more or less we'll do the same thing. Now, based on the result of this particular instruction, we can now execute this. If jump greater than or equal to, it means if AX is greater than or equal to C1, then which block we want to display here? If this is true, then we want to display L2. So we want to transfer our control to L2. But if it is not true, then certainly the number is less than AX is less than C1, strictly less than C1. So in that case, which block we want to display? We want to display L3. So L3, sorry. We want to display L3. And the same argument I can apply here, that the control will, here writing jump terminate is not important because the control will never reach this point. It means if this condition is true, then it will immediately take the control to this point. And if it is false, then this condition will certainly be true, and that way it will immediately transfer the control to this point. Okay, done. So now see here, why didn't I explicitly check one condition and then call this or transfer the control to left branch? Because you see here, jump greater than equal to, if it is true, then anyhow it is transferring the control to this point. And if it is not true, then obviously only one option left. I can do that checking and then transfer the control, but without now writing that condition also things will work in this, in the same way. What I meant is that okay, I can either write it in this way, or what I can do is I can write jump on less than. See, if it is not greater than or equal to, certainly one option left, that is less than jump. So we can write jump on less than to left branch, and then we can write what is this left branch is. So that way also it will work. Okay, then we can write what this left branch is. So that's my program more or less. It will display you whatever the largest number is. I mean, based on the value of this A1, B1, and C1, it will display you the, whether A1 is the largest one, B1 is the largest one, or C1 is the largest one. Let's first execute the program and see if it is correct or not. And so in this case, if I execute this particular program with these values, 5, 6, and 7, my output should be C1 is the largest one. Let's see whether I get this output or not. I compile the program. I link the program and then I execute. I'm executing it directly. I'm expecting C1 is the largest number. Here it is saying what? Oh, no. I'm executing the old program. PP, it is 9. It's a different program I wrote, right? A lots of errors. So 4, 5, 6 illegal instructions. Let me check. Oh, here I didn't declare it properly. I'm sorry for that. DB and DB. Does it make all the errors right? P9. Now, okay, no error, no warning, done. So we are ready to link the link PP99, that's all. And then I'm executing PP9, expecting C is the largest one. C is the largest number. Okay, let's change this value. Let's now make B the largest one by making B to 60. and compile this program and link this program and execute this program. B is the largest number. Okay, now let's make this CA is the largest number and execute the program, compile the program and link the program and then execute the program. A is the largest number. And then say make these two numbers equal. So 500 and 500. Then what will happen? Let's predict the output first before executing the program. Both A1 and B1 are same. So from this diagram also you can say this A1 is both A1 and B1 is same. A and B are same actually. Say for example A is 5, B is 5, C is say 1. Instead of writing 500, 501, 7, I've just wrote 551. You know, basically the same thing. Okay, now let's see. Okay, let me write here the actual values that those are there in the program. Yes. So what we're comparing here, first thing is A is greater than or equal to B or not. 500 is greater than or equal to 500. So 500 is greater than or equal to is there. So it is a true condition. So it is a true condition. It will come here and then it will check this condition. A is greater than C or not. A is 500 greater than or equal to 7 or not. 500 greater than or equal to 7, it is true. So it will come to this point and then it will display A is the biggest number. So if A and B both have same number, then it will display A is the biggest number. Let's see the output. In our case, both A and B have the same number, so it will display, and C is less than both of them. So in this case, it will display A is the largest number. Let's execute this program and check the output. Compile, run, link and run. A is the largest number. So most probably the program is right. Okay, and this is the program to find the biggest of three numbers. So what I request you people to do is you people also try to solve the problem completely from scratch by yourself. See here, it's just like these practices are important. They are like sort of going to the gym and doing exercise. And if you really want to make some good muscles, then you have to go to the gym. That is the first thing. And also, going to the gym is not going to be enough. Only looking at people lifting heavy weights is certainly not going to make any muscle for you. You also have to, no matter how small the weight is, but you have to actually lift weights. That's the point. It could be somebody might be lifting, say, like I don't know, hundreds of pounds. But you might not lift hundreds of pounds, but you might be able to lift, say, 10 pounds. So that will be enough actually for in your case. It will certainly make some muscles for you. The same thing here also. I mean, based on your level, you can always find some programs which might sort of uh, uh, challenges you, or solving them will actually build your um, mental muscles. These analogies, in many different aspects, I guess this analogy is true. So my request to you people is that you people try to solve this problem. You just get the question first. Okay, write a program to find the biggest of three given numbers in 8086 programming language, and then you start from the beginning, how you are going to write the code and why you are going to write the code. I mean, what is your logic, what logic actually you want to apply. So first decide the logic and then convert that logic using the programming language. Okay. Okay guys, then that's what I wanted to tell you in this video. Now see here, I have written the first program and the third one. Okay, and the second one and this one and this one I just leave it for you people. You people can try to write these programs, okay? And you people can let me know it in the comment section if you find them difficult, or any support you need, or anything, any clarification you need. Then you people can contact me. You can comment me in the comment section. Certainly, I'll try to help you. Okay, guys. Then that much only in this video. I'll see you guys in the next video.